Today, we're unpacking something that matters a lot to those of you working in the field: how pipeline inspections get prioritized, and more importantly, how smarter prioritization keeps you and your team ahead of problems. You already know this. Pipelines don't fail out of nowhere. There are signs, patterns, and risk factors. And the more we understand those, the better we can stay on top of integrity threats before they turn into downtime, leaks, or worse. At TPA, we've been using a new AI-powered tool called NotebookLM. Think of it like a corrosion-focused superbrain to help us build out a comprehensive integrity knowledge base. It brings together everything from fluid behavior to field inspection data, and it's helping us and the teams we work with make smarter, faster calls in the field. Let's start with the basics. Not all pipelines are created equal. You've got age, diameter, materials, operating conditions, even soil types. Each of these factors plays a role in whether a pipeline is at risk for corrosion or if it can keep running clean. So how do we prioritize which lines get inspected? Simple. We use data, but we combine it with field sense. First, age and material. Older lines and certain pipe types, especially bare steel, get flagged. We've seen time and time again that these materials corrode faster, especially when there's a change in operations or chemistry. Second, operating conditions. That means pressure, flow rate, temperature, and the type of fluids moving through the line. Higher pressures or lower velocities. That could mean water's sitting in low spots, and that's a red flag for internal corrosion. Third, the environment. Is the line buried in wet soil? Is it near a swamp or sitting next to cathodic protection systems from other facilities? External corrosion risk varies hugely depending on the surroundings. But here's where things get really valuable for field teams. We don't just look at the pipeline, we look upstream. If you're working in a gathering system, every pipeline is hooked up to a set of wells. And what's happening in those wells, like corrosion in the casing or tubing, can give you a heads up about what's headed downstream. We call it downhole-to-surface correlation. If multiple wells in a field show signs of internal corrosion, there's a good chance those fluids are also chewing away at your pipelines. That lets us prioritize inspections in areas where the risk isn't obvious from just the pipeline itself. And then there's historical data, ILI runs, repair logs, leak history. You'd be amazed how many issues get spotted by looking for trends across time. If a line had a history of MIC 5 years ago and hasn't been pigged since, that's one to watch. Now here's a concept we use all the time in our assessments: sibling pipelines. Let's say you've got 4 lines built at the same time, same diameter, same service, same coatings. If one of them starts showing damage, guess what? The others just got bumped up the priority list. Field teams can use this insight to get ahead of problems before they spread system-wide. And yeah, this isn't just done on spreadsheets anymore. We're talking advanced integrity models. These tools assign hazard scores to each pipeline segment. It's like a credit score, but for pipelines. The higher the score, the more likely that segment needs attention. But even with all this tech, it's not about replacing people. It's about empowering them. The best decisions come when data meets experience. When you've got boots on the ground knowledge feeding back into these models, that's when the magic happens. We've worked with ops teams that caught problems months before they showed up in an ILI run, just by connecting the dots between changes in production fluids and past corrosion behavior. That's the future of pipeline integrity. It's not just about inspecting more pipelines. It's about inspecting the right ones at the right time. And that's what TPA's deep dives are all about: bringing field teams the knowledge, insights, and tools to stay one step ahead. So here's your takeaway. Prioritizing pipeline inspections isn't about reacting. It's about seeing the full picture: wells, fluids, materials, pressure, and history, and acting proactively. Because in the field, the best kind of failure is the one that never happens. Thanks for tuning in.